There is a place on Earth where survival feels almost impossible. A place so extreme that even the toughest environments on land seem gentle in comparison. It is not a frozen tundra or a burning desert. It is a world hidden beneath miles of water, where sunlight has never touched and where darkness has ruled for millions of years. This is the deep sea, a realm so hostile that it feels detached from the rest of the planet. Yet it exists right beneath the waves we see every day. As you descend deeper into the ocean, the world slowly transforms. Colors fade, temperatures drop, and pressure builds to unimaginable levels. At great depths, the weight of the water above is so immense that it can crush steel. The cold becomes constant, hovering just above freezing. Food becomes rare, drifting down slowly from the surface like crumbs falling from a distant table. In this environment, every movement costs energy, and every mistake can mean death. And yet, life persists. Not only does it survive, it adapts in ways that challenge everything we think we know about biology. Some of the most astonishing inhabitants of this world are fish that appear broken by surface world standards. Fish with eyes that no longer function. Fish with eyes buried beneath skin. Fish with no eyes at all. Smooth faces where vision should exist. Empty sockets that seem unsettling and unnatural. At first glance, these creatures look like evolutionary failures, as if nature gave up on them halfway through. How could an animal survive without sight in such a dangerous environment? How could it find food, avoid predators, or navigate through endless darkness? For humans, vision dominates our understanding of the world. We rely on sight for nearly everything. From recognizing faces to avoiding danger, our eyes shape how we experience reality. Losing vision feels like losing control. So when we see animals that have abandoned sight entirely, our instincts tell us something must be wrong. But in the deep sea, the rules are different. Down here, darkness is not temporary. It is permanent. Light does not exist in any meaningful way. In such an environment, eyes become useless. No matter how advanced or sensitive, they cannot detect what is not there. Maintaining eyes requires energy, and in a world where energy is scarce, waste can be fatal. Eyes are among the most complex and costly organs in the animal kingdom. They require intricate networks of nerves, blood vessels, muscles, and specialized cells. All of this consumes valuable resources. In shallow, sunlit waters, this investment pays off. In total darkness, it does not. Over countless generations, deep-sea fish that wasted less energy on vision had an advantage. Those that redirected resources toward more useful senses survived longer, reproduced more successfully, and passed on their traits. Slowly, eyes became smaller. Vision weakened. Eventually, eyes disappeared altogether. What remains in many species are vestigial eyes, faint remnants of organs that once served an important purpose. These structures no longer function, but they tell a story. They reveal that these fish did not always live in darkness. Their ancestors once swam in brighter waters, where sight mattered. Vestigial features are evolutionary leftovers, traces of the past carried into the present. They exist not because they are useful, but because they are not harmful enough to be removed entirely. Evolution does not work with intention or foresight. It works through small changes over immense periods of time. The deep sea is filled with such reminders of history, written into flesh. Some fish still develop eyes early in life, only to lose them as they mature and descend into deeper waters. During their larval stages, they may live closer to the surface, where light is available. As they grow and move downward, vision slowly becomes irrelevant. Over time, the eyes degrade, shrink, or become covered by skin. Rather than seeing this as loss, it is better understood as optimization. In a place where food is scarce and movement is costly, efficiency determines survival. Any trait that does not contribute directly to staying alive becomes a liability. The deep sea strips life down to its essentials, but abandoning sight does not mean abandoning awareness. Fish that live without vision have evolved extraordinary alternatives. Instead of relying on light, they read the ocean itself. Water carries information in ways air cannot. Vibrations, pressure changes, chemical signals, and electrical fields all travel efficiently through liquid. Deep-sea creatures have learned to sense these signals with incredible precision. One of the most important tools for this is the lateral line system. This is a network of sensory organs running along the sides of many fish, capable of detecting even the smallest disturbances in the water. Through this system, fish can sense movement, direction, size, and proximity of objects around them. In darkness, the lateral line becomes a replacement for vision. The ocean, to these fish, is never silent. Every movement creates waves. Every living thing leaves a trail. To creatures adapted to read these signals, the darkness is not empty. It is filled with information. This is especially evident in fish that live in caves and underground waterways. These environments share many similarities with the deep sea: total darkness, limited food, and isolation. Cave-dwelling fish provide some of the clearest examples of how life adapts when sight becomes unnecessary. Blind cave fish are born with eyes, but as they grow, these eyes deteriorate. By adulthood, the fish are completely blind, yet they are not helpless. In fact, they are often more aware of their surroundings than sighted fish. Their lateral line systems are highly sensitive, allowing them to detect obstacles before making contact. They can sense the movement of prey, even when it is motionless to the human eye. Their sense of smell and taste are also enhanced, helping them locate food in an environment where every meal matters. These fish have also shown surprising intelligence. Studies have demonstrated that blind cave fish can remember the layout of their environment. They learn where obstacles are located and adjust their behavior to avoid them. This challenges the long-standing myth that fish have poor memory or limited cognitive ability. In total darkness, memory becomes a critical survival tool. Blind cave fish feed on whatever they can find. Insects, worms, snails, small fish, algae, and plant matter all become potential meals. When food is scarce, they conserve energy by reducing unnecessary movement. Their entire lifestyle is shaped by efficiency. Some species of blind fish have developed another remarkable adaptation: the ability to detect light through their skin. Although they cannot see images, they can sense changes in light intensity. When exposed to light, they instinctively move away from it, retreating deeper into darkness where they are safer. For these fish, light is not a resource. It is a warning. Interestingly, some species exist in both blind and sighted forms. The Mexican tetra is one such example. Within the same species, there are populations that live in surface waters with fully functional eyes, and populations that live in caves without eyes. Despite their differences, these fish can interact, share habitats at times, and even interbreed. This shows that evolution does not always create entirely separate paths. Sometimes multiple solutions exist within the same species, each adapted to a different environment. The deep sea operates on similar principles, but at an even more extreme scale. While some creatures abandon vision entirely, others take a different approach to life in darkness. Instead of giving up light, they create their own. In the deep sea, bioluminescence is one of the most powerful tools for survival. Bioluminescence is the ability of an organism to produce light through chemical reactions within its body. This light can be used for many purposes. Some fish use it to attract prey, luring smaller animals closer before striking. Others use it to communicate with members of their own species, flashing specific patterns to signal readiness to mate or to warn rivals. Some use light defensively, confusing predators or masking their own silhouettes. In the deep sea, light becomes a language, but bioluminescence comes at a cost. Producing light requires energy, and energy is precious. Not every species can afford it. For many fish, abandoning vision entirely and relying on other senses is a more efficient strategy. This is where specialization becomes critical. Deep-sea. Fish that lack eyes often possess extraordinary abilities in other areas. Their sense of smell can detect minute traces of chemicals in the water, allowing them to follow invisible trails left by prey. Their sense of taste may extend beyond the mouth, spreading across their skin to sample the environment directly. Some species can even detect electrical signals produced by the muscle movements of other animals. In darkness, electricity becomes another form of information. Cavefish and deep-sea fish often share these adaptations, despite living in very different environments. Both face the same fundamental challenges: no light, limited food, and constant danger. Blind fish are not clumsy or slow. They are precise. Every movement is calculated. Every behavior is shaped by millions of years of natural selection. In some cases, blindness is not a complete loss of eyes, but a transformation. Eyes may still exist, hidden beneath layers of skin or reduced to tiny structures incapable of forming images. These remnants are not mistakes. They are the result of gradual change. Vestigial eyes serve as evolutionary records. They show that traits do not disappear overnight. They fade as their usefulness declines. Vestigial structures exist throughout the animal kingdom. Snakes retain remnants of limbs from their ancestors. Whales carry pelvic bones from a time when their ancestors walked on land. Flightless birds still have wings, even though they no longer fly. Humans have their own evolutionary leftovers, including the tailbone, wisdom teeth, and small muscles behind the ears. These features are not signs of poor design. They are evidence of history. In fish, vestigial eyes tell the story of descent from brighter waters into darkness. They reveal migration, adaptation, and survival over immense timescales. One of the most unusual examples of adaptation to darkness is the blind swamp eel. At first glance, it hardly resembles a fish at all. Its body is long and worm-like, lacking scales and pigment. There are no visible eyes. It moves through mud and shallow water with an almost serpentine motion. The blind swamp eel lives in environments where oxygen levels are extremely low. Most fish would suffocate under such conditions. The swamp eel survives by breathing in a completely different way. Instead of relying solely on gills, it absorbs oxygen through specialized tissues in its mouth and throat. These tissues are rich in blood vessels, allowing oxygen to pass directly into the bloodstream. This adaptation gives the eel its distinctive reddish coloration, caused by blood vessels visible beneath translucent skin. The swamp eel can also survive out of water for extended periods. It absorbs oxygen directly through its skin, allowing it to move across damp surfaces or remain buried in mud during dry conditions. This ability to breathe both in water and on land gives it access to habitats that few other fish can tolerate. Although the blind swamp eel does possess eyes, they are covered by skin and no longer function. Vision has been completely replaced by touch and vibration detection. Its lateral line system allows it to sense its surroundings as it moves through narrow spaces. These eels are extremely difficult to find. They live in remote caves, sinkholes, and underground waterways, often buried beneath rocks or sediment. Their populations are limited and their habitats are fragile. In some locations, blind swamp eels share their environment with other blind fish species, creating ecosystems entirely adapted to darkness. In these ecosystems, sight has no value at all. Another remarkable inhabitant of these dark waters is the Mexican blind brotula. This small fish has no eyes whatsoever. Its skin is pale and translucent, giving it a ghostly appearance. But its lack of vision has not made it weak. The blind brotula has taste receptors spread across its skin. This allows it to detect food through direct contact with the surrounding water. Instead of searching visually, it tastes its way through the environment as a predator. The blind brotula feeds on crustaceans and other small invertebrates. In its isolated habitat, it has few natural enemies. Without competition from sighted predators, it has become one of the dominant species in its ecosystem. These adaptations show that blindness is not a disadvantage in darkness. It is an advantage. Beyond caves, beyond shallow underground waters, lies the deepest part of the ocean. This is the abyss, a place so extreme that even most deep-sea creatures cannot survive there. The pressure is crushing, the temperature is near freezing, and food arrives only as occasional debris drifting down from above. In this world lives one of the deepest dwelling fish ever discovered, the abyssal cusk eel. Despite its name, the abyssal cusk eel is not a true eel. It belongs to a different group of fish entirely. Its body is soft, flexible, and fragile-looking, perfectly suited to withstand immense pressure. Hard bones and rigid structures would be dangerous at such depths. Flexibility allows survival. The abyssal cusk eel has tiny, deeply set eyes that serve little to no purpose. These eyes are likely vestigial, remnants of ancestors that lived in shallower waters. In the darkness of the abyss, they provide no useful information. Instead, the cusk eel relies on an extraordinary sense of smell and taste. It can detect organic matter drifting through the water, allowing it to locate food without seeing it. Much of its diet consists of marine snow, a continuous rain of organic debris falling from the upper layers of the ocean. Marine snow may sound insignificant, but in the deep sea, it is life itself. The cusk eel moves slowly and efficiently, conserving energy whenever possible. Its motion is smooth and fluid, allowing it to glide through the water with minimal effort. When threatened, it can suddenly accelerate, disappearing into darkness before predators can react. Its body is often translucent, helping it blend into the surrounding water. In an environment where light is scarce, invisibility becomes one of the best defenses. The abyssal cusk eel represents the extreme end of adaptation. It exists at depths where survival seems impossible, yet it thrives. These creatures force us to rethink our understanding of strength and weakness. In the deep sea, success is not defined by speed, size, or aggression. It is defined by efficiency, specialization, and the ability to survive on almost nothing. Eyes, once considered essential, become unnecessary. Vision, once dominant, becomes irrelevant. What appears to us as loss is actually refinement. The deep sea teaches a powerful lesson about evolution. It shows that survival does not come from clinging to old advantages, but from letting go of what no longer serves a purpose. Traits are not judged by how impressive they look, but by how useful they are in a given environment. These blind fish are not incomplete. They are perfectly adapted to their world in the darkest places on Earth. Life has found a way to succeed by rewriting the rules. The deep sea is not a graveyard of failed designs. It is a showcase of nature's creativity and resilience. Perhaps the most important lesson these creatures offer is not about biology, but about perspective. What we see as limitations may be strengths in another context. What we consider disadvantages may be tools for survival when circumstances change. In a world without light, sight is meaningless. But awareness remains. And in the crushing darkness of the deep ocean, that awareness is enough to thrive. If you found this journey into the deep sea fascinating, your support helps keep these stories alive. Every comment, every thought shared becomes part of the exploration. Until next time, when we dive into another hidden world beneath the surface.